Alright guys, you have either attempted number 5 or you will be going over it with me for the first time. So we have two places. We have Sunset Wave, and it charges an entrance fee of $5 and an additional $2 per hour. Paradise Pool is a little bit more expensive per hour, but there is no entrance fee. So it says let's complete the ratio. So first off, Sunset charges the initial $5, but then it's only $2 every hour. If I add $2, it would be $7. If I add $2, it would be $9, so on and so forth. And you should have a table that looks something like this, 13, 15. Now, if I look at this, I already know this is non-proportional because it contains the point 0, 5 instead of 0, 0. So when I look to see if it has a constant of proportionality, I have to just do this ratio. Now, 5 over 0 is undefined. 7 over 1, 9 over 2, 11 over 3, 13 over 4, and 15 over 5. All these fractions would reduce to something that is not equivalent, and therefore it would not have a constant of proportionality and not be proportional. Now these guys over here, they have a $0 entrance fee, but every hour that you are there, it's going to be an additional $3. So every hour you stay, you pay an additional $3. Now let's see if this has a constant of proportionality. We have 0 over 0, which is just undefined. We have 3 over 1, 6 over 2, 9 over 3, 12 over 4, and 15 over 5. All these would reduce to 3. And since all these values are equivalent, I would have a constant of proportionality. Since it has a constant of proportionality, Paradise Pool has a proportional relationship. So it says graph both situations. Should the graphs be discrete or continuous? The first pool, I forgot what they're called. What is it called? Sunset Waves will do in purple. So Sunset Waves charges me $5 to get in. Then every additional hour, it charges me $2. So up 2 over 1, up 2 over 1, up 2 over 1. And I forgot to label my axes. This is hours. And this would be total cost. Let's put a dollar sign. And in this situation, it would also be discrete because you cannot pay for half an hour. You can have to pay an upfront fee of an hour ahead of time. So here, though, let's go and look at the purple, the next one. In blue, this is Paradise Pool. Paradise Pool charges $3 an hour. So go up 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1, and then up 1, 1, 2, 3 over 1. All right. So should the graphs be discrete? They should be discrete. And in this example, you can't pay half an hour. You can't pay for half an hour. Only whole hours. Alright, now it says state the rate of change for Sunset Wave. What does it represent? So Sunset Wave, I connected the dots so it's a little easier to see this. Now, when it says the rate of change, those are your stairs. That's the up and over. How much did I rise and how much did I run? How much did I rise and run, rise and run, rise and run? I went up 2 over 1, up 2 over 1, up 2 over 1. So it's 2 over 1, which reduces to 2. And this represents $2 per 1 hour. Now let's go and look at Paradise Pool. I'm going to use the green. Here, I go up 3 over 1, up 3 over 1, up 3 over 1. So using here, I can see the rise over run, the rate of change, the slope. They all mean the same thing. In this example, it's 3 over 1, which reduces to 3. And that stands for $3 per 1 hour. Write an equation that represents the cost per person, C, for T hours for each situation. So Sunset Wave the total cost is equal to, remember it's always rate of change times your independent variable. So, excuse me, I wrote this wrong. The total cost is equal to $2 per hour plus the $5 to get in. Where Paradise Pool is, the total cost there is just $3 per hour. The number in front of the independent variable, in this case it's h, is always going to be your rate of change. The plus or minus is what you have to pay on top of that. Now from the previous example, I know this is not proportional because it has a plus 5. I know this is proportional because it's just 3h. So which situation, Sunset Waves or Paradise Pool, represents a non-proportional relationship? Justify your answer. Now, I believe it was I keep forgetting. Let me see. Sunset Waves. Sunset Waves is non-proportional. Is non-proportional. Now the reason why it does not have a constant of proportionality. That is the y over x. That's when we got 7 over 1. So our examples were 7 over 1, 9 over 2, 11 over 3. None of those equaled each other. Now the graph was linear, but it started at positive 5. Because it did not go through the origin, it was non-proportional. Complete the table below and compare. I think we did this. Yes, we already did this one already. So if you have any questions on either the graphs or the tables or first difference or proportional versus non-proportional, please let me know. If you have questions with any of the homework, also please let me know on that. Remember, on Friday, we are going to be checking and going over 2.1b, 2.1c, and 2.1d homework. Alright, see you guys later.